Hello, my name is Mauricio, and for my lab assignment in CSE 548, Advanced Network Security, I will be doing a man in the middle. So this is just a really quick demo, um, specifically a ARP cache poisoning attack. And so what we would do is we will build a Python and Scapy script um, to do some ARP cache poisoning, and then after that, um, I'll show you how it works, and we won't have time to go into some of the further implementations and countermeasures, but that's all in the report, so you can check that out there. So first of all, this is the network topology that we have on ThoughtLab. So we have an external router that we don't have access to. And then this VM1 will be our attacker, VM2 will be our victim, and VM3 will act as the gateway because we don't have access to this. And so now if we go to the script that we will be running for our ARP cache poisoning, it's Python, and it uses the Scapy library, which is a packet manipulation library in Python. And so really quickly just through it, this first part is just getting input. We need interface, victim IP, gate IP. We enable port forwarding or IP forwarding. Then the getMAC function gets the MAC address associated with an IP address. This rearp function allows us to terminate correctly, right? So once the attack is done, we reset the poison ARP or spoof MAC address to the original correct one, and so that allows us to not be detected. Everything will work correctly after we're done, so it's terminating correctly. Then the trick function here is the important one, is the one that sends out the ARP replies with the spoof MAC address, and that's what allows us to poison the cache and get a man in the middle. So finally, we have our main function. When we put it all together, we make sure that we can get both MAC addresses because we don't want to be working on just one. So we have the try catch, and then in this while loop, we send out our ARP poisoning replies every 1.5 seconds until we get a keyboard interrupt, in which case we do the rearp to terminate gracefully, and that's it. So let's deploy the attack here on our ThoughtLab. We go to VM1, and we run the script, and the interface is F0, the victim is 192.168.1.5 and 192.168.1.8 is the gateway. So we can see here in the background Wireshark is running already, and we see that our attacker is sending out these packets that say, hey, 1.1.8 and 0.1.5 have this MAC address, and so because the ARP protocol has no security in mind when it was designed, it will just naively update those values to this, and we'll have a man in the middle. So we can check that here in our ARP caches for the other two machines really quickly. VM2, you can see that I've already run the I've already got the cache before it was corrupted or poisoned, and this is our attacker, that's the MAC address. This is our gateway, that's the correct MAC address. But once we have our attack running, we can do ARP.A, and we'll see that we'll have a poison cache, and we can do that on our VM3 as well while that runs. VM3. You can also see I got the ARP cache before, and this is the correct MAC address for our victim. And if we do ARP-A, and let me just get rid of this. So if we see here, attacker, and attacker successfully poisoned this MAC address. And then here we have again attacker, attacker's MAC address for the victim, attacker. So now we have successfully established a man in the middle with our Python script. And I think that's all the time I have for the demo. But if you want more cool stuff you can do once you have a man in the middle, and maybe to look into some countermeasures such as statically declaring these ARP caches so they don't change, you can look at the lab report, and it's a lot more detailed. This was just a really quick demo of the ARP cache poisoning